Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. Okay, we meet again in our online session. This time we will discuss about the final part in chapter 2. Okay. We will discuss about receiver. Okay. So the learning outcome, the student should be able to describe the basic super heterodyne system and super heterodyne receiver. Okay, receiver system, and explain why it is the preferred design for most receivers. So this is the keyword for today's lesson: super heterodyne. Okay, two important specifications are fundamental to all receivers. Okay, so today we discussing about receivers after we have discussed about the transmitter. Now we are at the end part this chapter, which is about the receivers. So two important specifications for all receivers. First is sensitivity. Second is selectivity. So sensitivity is the signal strength required to achieve a given SNR, signal to noise ratio, SNR, where selectivity is the ability to reject unwanted signal. So the ability to reject unwanted signal is known as selectivity. So when we talking about receiver, we should always remember about these two qualities. Okay. First is selectivity. First is sensitivity. Second is selectivity. Okay. Next, receiver topologies. Nearly all modern receivers use super heterodyne principle. Okay, so this is the keyword for lesson today: super heterodyne. The simplest receiver would consist of a demodulator connected directly to an antenna. So this is the simplest receiver. Is not super heterodyne. Okay, so modern receivers use super heterodyne, but before they use the super heterodyne receiver, they can use a simple receiver which consists of and demodulator and directly connected to antenna. Adding a tune circuit would improve the performance. So these are two basic receiver. You have demodulator, antenna, and some you have tune circuit. Tune circuit connected to the demodulator. We will discuss about this. We will see about this after this. Okay. So first, we will discuss about simple receiver. Okay. So this is before super heterodyne receiver. So we have simple receiver first. Okay. So what is simple receiver? You have detector, And you have antenna. This is antenna, right? This is detector. And this is speaker, speaker or earphone. Okay. So this is called Untune detector. You have antenna, you have detector, and you have speaker. Very simple. Okay. Then next you have the second one. The second one, you have tune detector, where this simple circuit is the tune circuit. The tune part of the circuit is added. So tune normally is a capacitor, tune capacitor. Okay, you connect one tune capacitor to the circuit, and they become tune detector. Next is addition of audio amplification. So this simple receiver, after adding the tune detector, they add the amplifier. Addition of audio amplifier, audio amplification. Okay, so these three basic or simple receiver circuit. Okay, first, untune receiver. Demodulator directly connected to antenna. So you have demodulator, you have antenna to receive the signal, and then straight away connected to detector or demodulator. It is similar. Demodulator. Any signal arrived at antenna would be demodulated. Detector output connected to sensitive headphone. Only strong signal received by good antenna will be heard. Receiver have no ability to discriminate signal. Okay, so there is no discrimination, no filter, nothing. So all the signal received will be connected to the demodulator or the detector. Okay, next is tune detector, where the previous circuit has been added tune capability. Okay, improve design by adding a tune circuit as input. Tune circuit improve selectivity, means that the receiver could be tuned to a particular station. Okay, so by adding the tune circuit, it improve the selectivity, can select the station. Okay, can select to a particular station. Signal at resonant frequency of tune circuit will be passed to the detector, and unwanted frequency will be attenuated or will be removed or will be filtered. Okay, unwanted frequency. So now you have some selectivity. Improve the selectivity by tuning this circuit. Okay, you know the tuning. Tuning is meaning you vary the value of this capacitor, and then only vary the value of capacitor, meaning changing the frequency, right? So only the frequency, the resonated frequency will be passing into the detector. The unwanted frequency will be rejected. Okay, so tuning meaning tuning the frequency. Okay, next is addition of audio amplification. The next improvement is adding the audio amplifier. Addition of audio amplifier provide enough output to operate a speaker. Okay, so you have the speaker or the headphone just now, right? Headphone or earphone, whatever lah. However, selectivity still poor due to single tune circuit. Okay, okay lah. One circuit, one single tune circuit is not enough. Receiver still not sensitive enough to receive weak signal, since demodulator need large input voltage. This demodulator is the detector lah. So this one need large input voltage with low noise and distortion. Okay, so to improve this circuit, you need to provide gain before detector. Okay. So now you have next the improvement. Okay. This is basically the same circuit. Same this one. So you have speaker. This is the audio amplifier, detector, and tune circuit. Okay. So detector, audio amplifier, speaker. Same, right? But okay. Now the next stage is the next improvement is tune radio frequency receiver. Okay. Tune radio frequency receiver. So now you have, instead of one here, now you have many gang tuning. You have many circuit for the tuning. And also you have amplifier here. Problem are in RF, radio frequency stages. To get satisfactory gain and selectivity, several stages is needed in this stage. Okay. All the tune circuit must be tuned together at same frequency, causing electrical and mechanical problems. Okay, now you have gang tuning, several stages of tuning and amplification. Okay, first stage here, tuning here, and amplification here, and then another tuning here and amplifier here, and another tuning here and amplifier here. Okay. Tune radio receiver. Okay, this is the description for the circuit before. Having several high gain tune amplifier stages in close physical proximity will cause oscillation, since it's hard to prevent feedback. In addition, it's hard to tune all circuits simultaneously. Variable capacitor have to be connected together mechanically, either gang, which is mounted on same shaft, or linked by belt. Gang meaning that when you move or you change the value of one capacitor, the other will change. Okay, so it is called gang. So basically it is mounted on same shaft. Okay. However, components tolerance cause the circuit to tune slightly different frequencies when their capacitors at the same position. This is the problem for the gang tuning. Another problem, bandwidth of tuned circuit does not constant when resonant frequency change, causing resistance to increase due to skin effect. Thus, a receiver with correct selectivity at low end of tuning range will have too wide bandwidth at the high end. Therefore, tune radio frequency only used for fixed frequency receiver. Okay. Okay, this is example calculation. Okay, you can calculate here. A tuned circuit tunes the AM radio broadcast band from 540 to 1700 kilohertz. If its bandwidth is 10 kilohertz at 540, what is bandwidth at 1700 kilohertz? Solution: the bandwidth varies with square root of frequency. Therefore, at the high end of the bandwidth will increase to, okay, so B varies with square root of frequency. F. So B equal to, using this equation. So if you have 10 kilohertz at 540, then what is the value at 1700? So now using this equation, you can get bandwidth is 17.7 kilohertz. Okay. Assuming that the bandwidth is correct at lower end, there may be interference from adjacent station at the top end. Okay. Okay, now we will see after that, so now you can see that our discussion is from the basic or simple receiver. We improve using tuning circuit, audio amplifier, and so on and so forth. Then at the end, we will arrive to the super heterodyne receiver. Okay, so now we will discuss about super heterodyne receiver. Okay, so super heterodyne receiver was invented in 1918 by E.H. Armstrong and is still using almost universally at the moment. Okay, a super heterodyne receiver is characterized by one or more stages of RF amplification. Okay, RF amplification, stages of RF amplification, and RF stage may be tuned or broadband. Okay, so this is the block diagram of super heterodyne receiver. Okay, so what do you have? You have RF amplifier, detector, local oscillator, intermediate amplifier, second detector, audio amplifier, and lastly the speaker. Okay, so you have seen this speaker from the previous simple receiver. So you have this. We have discussed about audio amplifier. Okay, and we have the RF amplifier, right? So basically, in super heterodyne receiver, they have some more improvement. Okay, first in this local oscillator, you don't have just now, and also this intermediate IF amplifier. Okay, so let's see what happened. So the antenna receives the signal. Okay, the antenna receives the signal. Weak signal picked up by antenna. Okay, you have this AM signal, right? You still remember this AM envelope. Okay, so the antenna pick up the weak AM signal. So this signal going into RF amplifier. Okay, so RF amplifier amplify the weak AM signal. So now it become big. Okay. Tuned and amplified by RF amplifier. These two voltages combine at the input of the first detector. Okay. AC voltage from local oscillator. Okay, now you have the weak signal have been amplified. So the small signal become big now. So the output here, the amplified RF signal combined with the AC voltage from local oscillator, the sine wave. This local oscillator produce AC voltage so that it combine in the first detector. Okay, so become these two voltage combined at the input of first detector. Okay, so you have the signal combined with the signal at the first detector. Okay, so then the output from first detector going into intermediate amplifier RF. Okay, bit frequency output from first detector. So this is the output from the first detector. The bit frequency amplified by intermediate frequency amplifier. So this input has been amplified by this intermediate amplifier. So it become strong signal now. Okay, the strong signal now. The second detector, the audio frequency output from second detector. So now the second detector, this detector here detect the audio frequency from the second detector. Audio basically the low frequency signal. Okay, audio is the low frequency signal from the second detector. So this audio frequency signal then being amplified by audio amplifier here, the audio amplifier stage, and then the output from audio amplifier being fed into the speaker. So loudspeaker change sound current into sound. Loudspeaker changes audio current into sound. So the audio signal, then you can hear the signal from the speaker. So this is basically the working diagram of the super heterodyne receiver. Functional element of super heterodyne receiver. Antenna. Okay, we have discussed about antenna. Band pass filter, RF amplifier, band pass filter, mixer, band pass filter, RF amplifier, detector, audio amplifier, speaker. Okay, the input filter and RF stage, put filter here, RF stage are referred as to the front end of a receiver. So this is it is called input filter here. And RF stage are referred as front end of the receiver. So here is the front end. Front end. Okay. The mixer, oh sorry, here, up to here. The mixer combines the signal frequency with a sine wave signal generated by local oscillator. Okay, local oscillator creating intermediate frequency. So at this stage, local oscillator always produce sine wave. Okay, so this local oscillator produce sine wave, and this sine wave combined with the signal from from this RF. The mixer combines the signal frequency with a sine wave signal generated by a local oscillator, creating an intermediate frequency. This is called intermediate frequency. So, okay, this is local oscillator plus the signal from RF. So, produce intermediate frequency. Okay. Okay. So, local oscillator here. Local oscillator plus mixer, call it converter. Local oscillator, tunable, generate fixed IF at 455 kHz. Frequency of desired signal, for example, the frequency of desired signal is 740 kHz. Thus, local oscillator will be set at 1195. So what is the number coming from? So this is IF, intermediate frequency. This is frequency desired. Okay, so local oscillator will be set to, this is local oscillator. Local oscillator minus frequency desired, you get the intermediate frequency. All this in kilohertz. Thus, 455 intermediate frequency is the value that will be passed to the next stage. This stage. Okay, intermediate amplifier. Mixer will also produce plus. Okay, this is a local oscillator plus desired frequency 1935 kHz, but the signal will be filtered out. Okay, because intermediate frequency, it is like plus minus, like sideband also. You have upper sideband and lower sideband. Okay. Okay. RF amplifier, this one. RF amplifier provide receivers gain and selectivity. Detector here to demodulate the signal. Okay, detector always known as demodulator. Okay, demodulator to demodulate the signal. Okay. Audio amplifier increase the signal power to a level required to operate a loudspeaker. So audio amplifier is to amplify the audio signal, to amplify the audio signal so that it can be sound. The sound can be heard at the speaker. Okay, to increase the signal power to the level required to operate a loudspeaker. AGC is the automatic gain control. Adjust the gain of IF stage, RF stage. Adjust the gain between RF stage, this one, and RF stage. Yeah, this is RF. This is RF. Okay. Example, AM broadcast receiver. This is example, the real circuit. So quite complicated, right? Normally, we will just give you the block diagram. This is called block diagram. See, everything is in block. Band pass filter, block, right? Okay. But the real one is like this. To add out, okay. Sorry. Example, AM broadcast receiver. Heterodyne converter is used where mixer and local oscillator use single transistor for stability and reduction of spurious response. Two methods, high side injection Local oscillator generate frequency higher than incoming signal frequency, or low side injection, local oscillator frequency lower than received signal. Okay, this is a simplified schematic, and this is block diagram of the super heterodyne receiver, AM receiver. Okay. So now we will discuss about the characteristic of the receiver. The characteristic of the receiver. Okay. Just now we have said that there are two, right? So first is sensitivity. Sensitivity, the ability of the receiver to receive weak signals with an acceptable SNR, signal to noise ratio. SNR. One common specification of AM receiver is that the signal strength required for 10 dB signal plus SNR at specified power level. Adjacent channel sensitivity is another way of specifying selectivity. Okay. Techniques like alternate channel rejection are also used to specify selectivity. So, yalah. Okay, there are few terms here that need further reading lah. Okay, if you want to further understanding of this theory. Okay, the second characteristic is distortion. Okay, number 2 is distortion. First is what? First is sensitivity. Second is distortion. Distortion comes in several forms. Harmonic distortions, when the frequencies generated are multiples of those in the original signal. Intermodulation distortion occurs when frequency component in the original signal mix and produce some and different signal. Okay, some and different. You still remember this? This is some is plus, different is minus, right? The third one is phase distortion. So you have 1, 2, 3. 3 types of distortion: harmonic, intermodulation distortion, and phase distortion. So phase distortion consists of irregular shift in phase and is common when signal pass through filters. Okay, there are 3 types of distortion. The third characteristic is dynamic range. Okay. The ratio between receiver response to weak signal and signals that are overload one or more stage is referred to dynamic range. Okay. The definition is quite maybe you need to rephrase. You can see what are other definition for dynamic range. Blocking may occur when two adjacent signal, one of which is much stronger than the other, cause a reduction in sensitivity to the desired channel. This is also referred to as desensitization or desense. So blocking also something related to dynamic range. Okay. Next is spurious responses. Super heterodyne receiver have a tendency to receive signal they are not tuned to. Okay. Image frequencies are signals that are produced as a result of generation of intermediate frequencies. So intermediate frequency, IF, is some issues are image frequencies. So what is image frequencies? So image, this is image. Okay. Image frequencies are signals that are produced as a result of generation of intermediate frequencies. Okay. So next is about demodulators or detectors, recovering information signal. So we have discussed in the earlier in the part of the chapter that the demodulator, one of the most important function at the demodulator is to recover the information signal, right? So that the modulated signal at the transmitter will be recovered, will be detected and recovered, changed back to the original signal. So demodulator's function is to recovering information signal. The demodulator, also known as the detector, see, demodulator or the detector, is part of the receiver that recovers the baseband signal. It performs the inverse operation of the transmitter modulator. So at the receiver, there is a component which is called detector, which perform the inverse operation of the transmitter modulator. There are several types of modulator used depending upon the types of modulation used. Okay, so the demodulator types is depending upon the modulator types. Okay, okay. First type of demodulator is the full carrier AM. Full carrier AM demodulator. The simplest, most popular demodulator for full carrier AM is called envelope detector. So what is envelope detector? To recover the baseband signal, the incoming signal is simply rectified to remove half of the envelope, then filtered to remove the high frequency components. Okay, first type of demodulator, the simplest one is called full carrier AM, also known as envelope detector. Okay, so you still remember this? This is amplitude modulated signal, AM signal, basic signal. You have two side, plus minus. This is called envelope, right? So this envelope, you need to change this envelope into the AM signal. So what happened is, using this circuit, this is called envelope detector. So how it works? First, the incoming signal here is simply rectified. Rectified is diode. So it will take the positive part of the signal. The negative part will be removed. So that is the rectification process. The incoming signal is simply rectified. Remove the half of the envelope. So we'll remove the half of the envelope. Then filtered. Okay, here the capacitor here, and the resistor here become the filter circuit. Okay, this will be filtered to remove high frequency component. So then the output here is low frequency AM signal, envelope of the input. So the output is the low frequency, the envelope signal. Okay, that is the simple explanation lah about envelope detector. The basic demodulator full carrier AM circuit. Okay, so this is a little bit of explanation of the same. So now you have this envelope here. Here you have envelope. Then at point B, after this diode or the rectifier, so at point B you have the negative part of the signal is gone. Okay, so now you have the positive part. Okay, then at point C, At point C, you have this signal, the low frequency signal. After the high frequency has been removed, and at point D, you is the signal has been shifted to the center at the 0 volt. Okay, 0 volt center. So now you have positive and negative, peak to peak. So basically this is the envelope detector circuit. Okay, second demodulator circuit is known as, this is the second, single sideband suppressed carrier AM demodulator. So we have discussed about this in the transmitter part. So now when it arrives at the receiver, so we need to be able to extract the information of that suppressed carrier AM AM signal. A diode detector alone will not work for single sideband or double sideband suppressed carrier because the envelope is different. Yeah, the envelope is different. Typically, a product detector using a balanced modulator is used. So this you can search yourself about details about this single sideband suppressed carrier AM demodulation circuit. Okay, so basically the circuit, you have single sideband signal go into the balanced modulator, and then it goes into the filter. The output from the balanced modulator, at the balanced modulator, you have the signal mixed. The incoming signal will be mixed with the signal from carrier oscillator. So this signal plus this signal at the balanced modulator. So you will have two different signal, two different frequencies. One is plus and one is minus. Okay, so this is they call it what, plus and minus, plus and minus. So after that, both signal go through low pass filter, and then you get remove the high frequency signal, and you get the low frequency signal, recovering modulating signal, or also known as intelligent signal, or the voice, or whatever lah. So this is basically the block diagram, how this simple explanation how this single sideband suppressed carrier AM demodulation circuit function. Okay, in terms of communication receiver, it is used mainly for general purpose receiver that cover a wide range of frequencies from 100 kHz to 30 MHz. Generally, communication receiver divide their coverage over several bands. Okay, components of communication receivers. So this is example. Squash disables the receiver audio, the absence of a signal. Noise limiter typically use a diode limiter or clipper in the audio section of the receiver. Okay. Okay, next is transceiver. So what is transceiver? So it is combination of transmitter and receiver. So transceiver is simply a transmitter and receiver. Transceiver and receiver in one box. Okay. So one equipment which can function as transmitter and also receiver in a box. It calls transceivers. Transceivers are convenient and allow certain economies to be made. Certain saving. Okay, low cost, cut cost we made. Most transceivers operate in the half duplex modes. Still remember half duplex? Full duplex? Simplex? So most transceivers operate in half duplex. So you still remember, right? So you have simplex, half duplex, and full duplex. So transceiver function in this mode. Okay. Okay. Last is receiver measurement. So the receiver, as we have discussed previously, we have mentioned the most important characteristic of the receiver are: first, sensitivity, measured with the calibrated RF signal generator and audio voltmeter, and second is selectivity, measured with RF signal generator. Okay, with that I end this presentation. So I think we have we have finished our time. So that's all. Thank you for watching. Until we meet again, I hope you can understand a little bit about the receiver. So after watching this topic, so we already finished chapter 2. So after this, we will go into the next chapter. Okay, that's all. Thank you very much for your attention. Thank you. Assalamualaikum warahmatullahi.